This means it's a neutralization reaction. Okay, to give carbon dioxide gas. So Y contains if you use sodium carbonate, it can react. It can only be one functional group, right? So Y contains carboxylic acid. Yeah, that's right. Okay, so as a result, you can actually tie it in with the first reaction, which is if I see there's a nitrogen, and then the nitrogen undergo this dilute sulfuric acid reaction, right, to form a carboxylic acid, and then the nitrogen disappear. So most likely, it's either a nitrile that undergo acid hydrolysis or a primary amide that undergo acid hydrolysis, right, for nitrogen. So which one is it? For X, starting there's no oxygen, so it cannot be an amide. It can only be a nitrile. Okay, so the type of reaction is acid hydrolysis. The functional group change. The functional group is a nitrile that turn into a carboxylic acid. Okay, so there are 6 points here, right? So it could be that it is 4 out of the 6 to get just 2 marks for deduction. Okay, so sometimes they do not need you to have all exactly, to be to get the full marks. Yeah. Okay, so X will have a alkene and a nitrile, and then you hydrolyze, you have an alkane and a carboxylic acid. Okay, so 1A we start simple with 3 carbons. Any questions? Okay, let's move on to part B. So for part B, it's slightly more challenging in a sense, where you start with 5 carbons, 8 hydrogens. Straight away you will think, okay, I have 2 degree of unsaturation, right? A degree of unsaturation of 2. You're able to reconcile that, right? C5 should be H12, right? C5 H2N plus 2. So 12 to 10 is 1, 10 to 8 is another 1. So degree of unsaturation 2. So it could be 2 double bond, 1 double bond, 1 cyclic, or 2 cyclic, or 1 triple bond. Okay, but it cannot be 2 cyclic for 5 carbons. Okay, so it's either of that. Okay, next. Where's my eraser? Yeah. If decolorized equals bromine, so this will be electrophilic addition again. Alkenes present. Okay, and then there's this part. It says give off white film when reacted with PCl5. What does this mean? It means it has a OH group, not necessarily alcohol. Okay, because carboxylic acid also can react with PCl5. Okay, so how do we know it's alcohol, not carboxylic acid? Because you only start with 1 oxygen. Okay, so it's nucleophilic sub, alcohol present. Then the key here is when you react with acidified potassium manganate, right, you expect oxidative cleavage of the alkene that you have previously identified. Okay, so if you cut the CC double bond, it should give you 2 separate products if it's a straight chain. However, there's only 1 product and the 5 carbon remain. Okay, so this is your key clue to tell you that A was cyclic, such that after you cut the double bond, it still remain as 1 product. Okay, so the reaction here is oxidative cleavage. Okay, and as well, just now you identified there's alcohol. Now this alcohol is oxidized. Okay, so now you think about it, right? If I start with 1 oxygen, I end up with 5 oxygen. Secondly, if I have a CC double bond, okay, if I cleave this CC double bond, it's going to end up COOH on both sides. Okay, this is for terminal. Okay, when you have the C not connected to any other alkyl groups. Okay, now for 5 carbon, this is most likely the case because when you draw 5 carbons, you draw a pentagon, right? You draw a CC double bond. If you cut here, yeah, you're going to end up with COH. The only case where you're not going to end up with COH, right, is when you have a fully substituted alkene, right? That means you have a C that's joined to two alkyl groups. Now, if you have this, then your product will have ring strain, because now it has to be like this. Okay? Now, why is it not like this? If you cut this one, you're going to end up with a COH on the left. You're going to end up with a ketone on the right. Now, you have one more alcohol here. This will end up with another ketone. You only have 4 oxygen. Sorry, that's too big. 1, 2, 3, 4. But the question says it becomes 5 oxygen. So obviously it's not this one, for 2 obvious reasons. Number 1, there's ring strain. Number 2, you don't have the correct number of oxygen. Okay? So it can only be this one, this pentagon shape. Then you have to put an alcohol in. The last clue is that it has to be a symmetrical product. So for symmetrical product, your alcohol can only be at this part. Right, if you put on any other carbon, then it's not symmetrical. Okay, the next part here is just confirmation of what that B structure is. Will be a ketone in the middle, COH on the ends. Okay, so no oxidation, that's the reaction. The reaction is oxidation, but there's no reaction. No oxidation. Then condensation at 240 mph. B is a ketone. Acid-base neutralization contains 2 COH groups. Okay, so this one, take note that for every 1 COH, react with half Na2CO3. Okay, so if it react with 1 more Na2CO3 means there's 2 COH groups. Okay, so I'll try my best to go through questions 2 and 3 without telling you the structure, just tell you the deduction, right? I mean, just go through the thought process with you so that you can do it on your own when you have the time. Alright, for question 2, we start with 10 carbons, so a bit scary, but don't be scared, okay? We see the 10 is to 15, likely you can guess, most likely could have a benzene ring, alright? Is soluble in both dilute acid and dilute alkaline, means it both have a basic group that can react with acid, as well as it has acidic groups that can react with NaOH. However, no gas is evolved when sodium carbonate is added. Now, sodium carbonate is a distinctive test for COH. So this tells you there is no carboxylic acid groups. Okay? So it does not undergo acid-base neutralization. That's the reaction with carbonate. So no carboxylic group, that's the functional group deduction. So how can you have an acidic group that react with NaOH but not with carbonate? It can only be if you think in terms of organic chem, the topics you learn, at carboxylic acid, it's not carboxylic acid, then you have to work backwards. You don't work forward, because forward you go to a nitrogen compound, become basic, right? So work backwards. What's the next nearest topic that has an acid inside? It's a phenol. Okay? So if I have reaction with 2 more NaOH I want to do, that means there's 2 phenol group present. Okay, 2 phenol groups present. So somehow I have to fit 2 phenol groups into this benzene ring. I also have to fit an additional 4 carbons to the benzene ring, because benzene ring 6, right? There's 10. Okay, I'm just gonna skip the middle chunk, because you realize the answer lies at the very end here. Okay, so on hitting G with acidified potassium manganate, the products form H and I. Okay, so you have a benzene ring with potentially 1 side chain, 2 side chain, or 3 side chain, I don't know. At this stage, right, I'm just thinking, I have phenol, right? So one phenol, here, one phenol. Then somehow I need to fit 4 carbons. So if it's single chain, right, it's like that, 4 carbon, right? It could also be cyclic for all I know, right? I don't know. But the clue is here. Then after this oxidative cleavage, there are 2 products. One of them has 3, so H must have 7 carbons. Okay, so that means there's only one side chain, one alkyl side chain. Okay, now this test, right, could potentially also be oxidation of side chain. Now I've told you the answer already, okay, but without revealing too much, so I have 2 OH groups. If I put the most ridiculous case, is I put 4 carbons like that as 4 side chain, and then I do the acidified KMnO4, right? I'll end up with COH here, right? That's the idea lah. You will retain all 10 carbons, so it's not this one, okay? Okay, so E reacts with hot KMnO4, hot K2Cr2O7 to form F. So obviously the type of reaction is oxidation, but it's not the side chain oxidation. It is potentially of, okay, we have 3 oxygen. We know 2 of them are phenol. So there's 1 more oxygen left. This one last oxygen could be ketone, could be aldehyde, or could be alcohol. So this last oxygen, we know phenol doesn't react with K2Cr2O7. Okay, so this one will be oxidation of the alcohol to form F. F could then be an aldehyde or ketone. They didn't say with distillation, right? So form aldehyde, you need to have distillation. So more likely this is a ketone. And then it confirmed with 2,4-DMPH, but not toluen, right? So what's the type of reaction 2,4-DMPH? The name for this start with C. Condensation, that's right. Then reaction with toluen, it's called oxidation. So you say no oxidation, right? Okay, the type of reaction you say oxidation, no oxidation with toluen. Right, undergo condensation with 2,4-DMPH, no oxidation of toluen. That is the mark for the deduction, right? Then you deduce that it's a ketone. Okay, so upon heating E, this one with Al2O3, you should figure this is elimination. Okay, so G will be alkene, then this is oxidative cleavage of the alkene. Alright, so let's move on. Any questions for 2? So I'm not going through the answer because you haven't done it. Do it on your own, then check the answer key. The answer key is quite self-explanatory. Alright. Now for question 3, let's take a look. We have 11 carbons, 10 hydrogens, so likely there's a benzene ring as well. But now I have to arrange 5 more carbons around the benzene ring. Oh, tough job. Okay. Neutral FeCl remain yellow, so no phenol. Because neutral FeCl3 is the reaction test for phenol. No phenol. S gives silver mirror with the diamine silver complex. This is what reaction? I know it's toluenes, but that's not the name for the deduction, right? The type of reaction is oxidation. So S undergo oxidation to give, so the functional group here will be aldehyde. We do not yet know aromatic or aliphatic, both also can. However, S does not give PPT with hot alkaline CO2+. This is your failings. The reaction for failing is oxidation. So there's no oxidation with failing. Means it's an aromatic aldehyde. Okay, so we have confirmed one functional group based on the first sentence, first paragraph. So as heated with acidified KMnO4, your aldehyde is going to be oxidized, yes. But at the same time, your methyl side chain, right, is going to be oxidized as well. Then there's 1, 2, 3 tricarboxylase. Wow. So that means there's 3 side chain, right? So you have 5 carbon. You know, arranged around the 3 side chain. 1, 2, 2 maybe? Or 1, 1, 3? These are the only 2 possibilities. When heated with NaOH, this is alkaline hydrolysis, followed by acidification. As from this, so the number of carbon remain. So after you hydrolyze, the number of carbon remain the same. Remember question 1? 1b. You cut the thing. You're supposed to have 2 products, but it end up is still 1. Means there is a cyclic side chain, yeah. So out of your 3 side chain, imagine you have your benzene like that. Firstly, you have your aldehyde. Then out of your 3 side chain, 2 of them will join up together. And it cannot be like this. Please don't do this. Okay. It should be the neighbors. Okay. So either like there, somehow join together, then one more here. Okay. So you try to figure out. Lastly, alkaline aqueous iodine to give yellow PPT. So you must have that CH3 group, right? Okay. So here you hydrolyze. You have oxygen. You hydrolyze. There's no nitrogen. So likely the thing that you're trying to hydrolyze is an ester. And then after you hydrolyze the ester, the alcohol group is the only one that can give you your aqueous iodine. So make sure that when you draw your ester, the alcohol side here, this carbon, right, remember to give it a CH3. So that it can then undergo this triiodoform. Alright, so the last one is just a reduction, in case you have forgotten. Okay, that's all.